Welcome to the E6S Methods podcast with Jacob and Aaron, your weekly dose of tips and tricks to achieve excellent performance in your business and career. Join us as we explore deeper into the practical worlds of Lean, Six Sigma, project management, and design thinking. In this episode number 181, we speak with reliability expert Fred Schenkelberg and get his take on the day in the life of a reliability engineer. If you're just tuning in for the first time, find all our back episodes on our podcast table of contents at e6s-methods.com. If you like this episode, be sure to click the like link in the show notes. It's easy, just tap our logo, click, and you're done. Tap, click, done. Here we go. Fred Schenkelberg is an international authority on reliability engineering. He is the reliability expert at FMS Reliability, a reliability engineering and management consulting firm he founded in 2004. Fred left Hewlett-Packard's reliability team, where he helped create a culture of reliability across the corporation to assist other organizations. His passion is working with teams to improve product reliability, customer satisfaction, and efficiencies in product development, and to reduce product risk and warranty costs. Fred's areas of expertise are reliability program development, accelerated life test design and analysis, reliability statistics, risk assessment, test planning, and training. He has a Bachelor of Science in Physics from the United States Military Academy and a Master of Science in Statistics from Stanford University. Fred Schenkelberg, welcome to the E6S Methods podcast.
Thanks for the invite, Aaron. I much appreciated it.
Yeah, my pleasure, and thanks for squeezing it in such short notice.
No problem. I know how it goes.
So I first came across you, I think, maybe through Twitter, and noticed you have your Speaking of Reliability podcast, which I do subscribe to. As a matter of fact, I subscribe to all the podcasts that are in your network. I think when I first started listening to your show, I had an idea of what reliability was, but that's why we're on here, just to see, hey, you're an expert in reliability. My listeners may not be experts in reliability, so what is reliability? And let's start there. What is reliability in your mind?
The easiest definition is just about any product or even service, into these days even websites that you go to. If it doesn't function, doesn't deliver the value that you expected it to. So if the website crashes, or if your car doesn't start, or if your microwave stops microwaving, or whatever the appropriate verb is for what those things do. When you lose that functionality, it's a failure, right? We didn't get what we expected.
Right.
And it can happen because it wears out. It could happen because there's a manufacturing defect. It could happen because there's an outside stress that's been applied to it, like you drop your phone and it breaks. Mm-hmm. It has some force applied to it. Any of those things that create a disruption in the service is a failure. And so reliability in the work of reliability engineers is to create the proportion of successes to be a very high number. And likewise, the complement is the number of failures to be very small.
Right, okay.
So that's the easiest thing. It's just anything that doesn't deliver its function is a lack of reliability.
Now, I've heard and so see if this makes sense to you, because it hasn't made sense to everybody I've spoken to. I've heard somebody put it as reliability or quality being reliability at time zero. Does that strike a chord with you?
Yeah, I've heard it. It depends on who you're talking to. If you're talking to a quality professional and kind of a Deming and Duran disciple, they will say that reliability is one of the characteristics of a quality product. And I beg to differ in saying, well, it's reliability is quality over time.
Yes.
And so it can go either way. It's kind of irrelevant. For companies, and especially companies providing a product in, say, like a consumer market or B2B market where they have a warranty or an obligation for repairs, if it costs you money after you've sold the product to service that product or repair it or make it right or replace it, that's a lack of reliability. And so it's a failure of your product. It doesn't matter whether it was the wrong color or the color faded. Somewhere in our product design and development process, we got that wrong, and that's a failure. And so it gets into semantics at some point, whether you call it a quality issue or reliability issue. Right. It still goes back to, did we design and manufacture it correctly?
Is there a corollary between reliability engineering or maybe you're calling it reliability engineering, But there's a deep usage of statistics within that discipline, correct?
Oh, definitely. Well, are you familiar with the American Society for Quality, the CQE and the CRE, Certified Quality Engineer and Certified Reliability Engineer?
CQE, yes.
Okay. So you take all of the statistics, which is in the CQE, which is sample size calculations, some test planning, hypothesis tests, design of experiments, confidence intervals, all of those kinds of things, right? And then add time to failure, the statistics of the failure rates, and a whole other class of distributions like the Weibull distribution. The CQE tends to focus on the normal distribution because it's used in control charts and tons of other places. Where reliability is, we don't have that negative infinity. We always start at time zero when you're looking at time to failure. So it's all of that other stuff because you still need to worry about process control. You still need to worry about variance and sources of variability and stability and all of those things. And we have the added statistics of what we use in warranty analysis and a variety of others is to say, well, how long is it lasting long enough? Is our test designing to do accelerated life testing, which is heavy in statistics, and field data analysis heavy in statistics? So it's fair to say there's a lot of statistics.
Okay. So so you mentioned reliability in service. Is this overlapping at all with actuary sciences when we get into those other types of industries?
There are. I think it's where, I think you probably are familiar with it as much as statistics started because gamblers in the court of France wanted to earn money from their peers. So
I did not know that. Okay.
Yeah. So a lot of the very fundamental counting practices, the set theory stuff we did and ors and permutation combinations, that kind of basic probability stuff came from gambling way back 16th, 17th century. And of course, it's developed over the years. There's a lot of overlap. There's a lot of use of statistics only because the only way to know if you're right in reliability, I call it euphemistically the Microsoft method, is you build a product and give it to your customers and let them tell you what to fix.
Right.
To be fair, the folks at Microsoft do have an incredibly complex operating system and spend a ton of time, shaking it out before they send it out. But it is that complex, and not many companies can afford to do that. So there is due diligence up front. It's a lot of fun trying to predict the future. Whereas with the quality sciences, is it in spec? Generally, does it meet our requirements? Is it going to be produced regularly? But the actuary sciences out of the insurance companies is trying to forecast the future. What's the bet on what size warranty expense are we going to have, which becomes pretty significant depending on your product line. So there's also some overlap with medical sciences of the science that the Center for Disease Control, CDC, uses to look for outbreaks.
Oh.
So if you're looking at field data and you're seeing a spate of failures, there's markers in the types of failures you're seeing and the signals you're seeing, if you're looking at your data well, to signal that this is an outbreak of something we need to get ahead of, or it's just normal background noise of routine events. And so we go from that.
So they say that Google predicts the flu better than any or predicts the outbreak of the flu because of search terms of the flu. Might they be sticking that into some big data into some sort of distribution?
I don't know how they do that. There's probably just looking at trending. If you see it, everybody in Cincinnati is looking for flu remedies. It's probably a good bet that correlates that there's an outbreak there. It brings up an interesting idea. We should monitor review sites like Yelp and others on products to see if there's an outbreak of product recall.
Oh boy, that's interesting. Yeah,
we might have to cut that out, Aaron, because we might have a new product we'll have to cut.
All right. So how did you get started in the reliability field?
Well, I was more along the lines of your podcast, Aaron, is more in the process control and quality statistics. I was doing design of experiments in a factory. And the design team would not budge on making improvements to improve yield. Mm-hmm. The yield was already good, and it wasn't a good ROI for them to change something so we could make it easier. But when I connected those changes that we didn't have to do repair or rework on boards, on circuit boards in particular, or if it was just more robust in the manufacturing process, it tended to be more robust in the field. So I started connecting the return of a change I was requesting to the field reliability. And that, for the product I was working on, was big money. And so I started exploring that more and more. Somebody let other folks know that I knew a little bit about statistics, so then I got tagged with doing accelerated life tests.
You became the stats guy, yeah.
Became the stats guy, exactly. And I enjoyed it. I got a master's degree about that time in statistics, and it's served me well ever since. But that's basically how I got started. My boss walked into my office one day and said, I was making a heating cable, and he said, "Can you figure out whether this will last 20 years or not?" And
give me 20 years.
Okay. Yeah, I said 21 years. Yes. I need a little margin. And he goes, "No, you get 6 months."
Okay.
So, yeah, I kind of dove into the deep end of degradation accelerated life testing. That was my first real project in the field, and yeah, it's been an enjoyable journey ever since.
So you mentioned accelerated life testing. So would that be a typical day in the life of a reliability engineer, is breaking things and measuring how long it took to break them?
I'd like to say yes, because that's really the fun part. Mm-hmm. I think most of the work is not different from most of what we do is in engineering. It might take you a day or half a day to design a test. Here's how many samples I need. Here's the stress levels. Here's how I'm going to measure it. And then it'll take you 2 months to get funding, to gather all the equipment, to procure all the pieces you need, get a chamber. It's all the bits and bobs of making it all come together. Design reviews, meetings and discussions. It's risk analysis, FMEA type work. It really, really varies from everything from reliability modeling and prediction type work to accelerated testing. Reliability isn't testing, like quality is not just testing. Mm-hmm. There's a lot of parallels in that regard.
So you mentioned getting samples, running sample size calculations. Now, when I was at Pratt & Whitney, they would they'd do their life testing on a sample of one, but that was one very large engine that cost $2 million and thousands of components and another 1,000 ways to measure everything as failures were occurring. So what is the trick with getting the right samples and making sure that you don't spend too much money trying to understand how these things will fail in the field?
Well, yeah, it's only one time I've ever had enough samples, and it was for a solar panel company that was making these big fields, and the cables get routed on the backs of these frames, and they use zip ties, these little plastic, you stick one end into the other one and it pulls it tight, zip ties to hold the cables on. Well, after a few years, these cables were failing. They were oxidizing and becoming brittle, so any wind vibration over the top of the panel would create enough chatter in those cables that it would break them. And then they bought really cheap connectors, so the connectors would open and they'd lose whole strings of solar panels and their energy output would drop. And it cost them a lot of money to send somebody out there and go reconnect everything and re-zip tie them all.
Oh,
and so we did an accelerated test on 3 different brands of zip ties, and I had thousands and thousands of samples. It was great. The limit was we were doing Instron tensile strength tests on these things, so I was limited by how many I could actually test in a day. But that was the only time I've ever had enough samples. But to answer your question, it really starts with you have to have a really clearly defined problem you're trying to solve, and what does it take to get a satisfactory answer, a decisive answer? Is this reliable or not, or it's not, or it's in control or it's not, or it's in spec or not, based on sampling. And the big expensive stuff is we do a lot more modeling and looking for exactly where we want to measure to look for those precursors or degradation type mechanisms versus something like a zip tie is we just age a gazillion of them and measure them. But it's every single time I've sat down to do sample size, it's always a balance between, well, what risk are we taking that the sample represents the population? How precise do we need to be in the result? And what's the variance of what we're trying to measure? And those three things play a role in determining a sample size.
Like you said, the risk. So the amount of testing for, again, a jet engine would be quite a bit higher, obviously, than a zip tie, even though using that consumable in that application made it very expensive for that group. But the you know, if you're a zip tie manufacturer, somebody's using it in a manner that you kind of didn't expect. You're going to release the zip tie that doesn't have to last 10 years UV exposure on the high winds, right?
Yeah, with the zip guys, we actually talked to them and find out about their formulation and process and stuff, and they said, "Well, just put more zip ties on." If you're out there, you got to clean the things anyway every couple of years. Just walk around the back and add more zip ties. It's like, I think that's what they ended up having to do, is just made it a part of their maintenance program. And they also thought about going with metal ones and other ones, but when you got a couple 100,000 zip ties or cable attachments to take care of, it got expensive real quick. You asked about the day in the life, and some of it is the engineering, trying to just solve problems and working with design teams or a factory to look at their equipment or their design or their process or their new product or whatever it is. Part is, do we have the infrastructure and the knowledge to evaluate what could go wrong? What are the risks? And then for the areas that have more uncertainty, like we just don't know, so let's test that part. How does it behave at minus 40 degrees C, for example? What will it do? Will it work? And then a good part of the day is spent just implementing that, setting up meetings, coordinating schedules, writing reports, test protocols, the typical engineering tasks other than the fun stuff. And then it flips over once we get failures, whether in-house or in the field, that we often get involved with failure analysis, and then whether it's process or vendor or design changes to minimize those failures going forward.
And I see in your bio that you have a bachelor's in physics as well. Is physics and statistics a unique combination for something like reliability?
I don't know. I've run into a number of other physicists that are working in various fields in engineering. It's a pretty broad science discipline, right? So you can go pretty much anywhere with it. It was just happenstance. I didn't know what I wanted to do. And I think I took some courses in civil engineering. I took some courses in electrical engineering, a bunch of math courses. In undergrad, there was very little statistics available. From what I understand, talking to graduates these days, is that statistics is, in general, just not a required class anymore, which I think is unfortunate.
I had a colleague when I left college, and he came from Clemson. He was a chemical engineer. I'm a chemical engineer. He said to me, he's like, well, what did you do in your college statistics class? So I said, oh, no, I didn't take statistics. It wasn't required. He looks at me, he goes, that was a really big miss on your college. And I said to him, like, whatever, I'm fine. About 3 years later, I finally took statistics. I was like, oh my God, I can't believe I didn't have this all along.
Yeah. There's so many demands on graduates these days, and just the course load and the variety of things they got to take. I think part of the strategy in some schools is just build it into the labs, build it into some of the other lessons. But you know firsthand, right, a couple of mentions by a professor to make sure you calculate standard deviation is not enough of a grounding in the science. I think it's a miss on campuses that don't require it.
I remember one day getting a photocopied piece of paper with the formula for standard deviation on it and getting no other instructions other than make sure you calculate the error. And nobody calculated the error, but it didn't affect our results. No, not at all. So,
yeah, I don't think that's suitable. Reliability also, though, is we've talked a bunch about statistics. It's also the culture of an organization. Reliability is hard to measure during the development process, but cost and time to market and the feature set you can all measure immediately. Yet if you take shortcuts on cost and you rush the market and all those kinds of things, your product has a higher risk of failing. And balancing that and understanding what those risks are is a big part of what reliability engineering is about, is quantifying the potential future risk. And I think your comment about actuarial sciences, because it does feel like you're selling life insurance sometimes to healthy people.
Right.
It's it's not all that. We walk into the room and talk about all the things that are going to go wrong. But if the culture in the organization celebrates failures, understands that those are areas they can actually make an improvement and can claim market share, they can make more robust products, the better understanding of how people use their products, those are all great. Or an organization can say, well, failures are bad. We're only going to test to success. We're going to ignore all the failures as customer abuse, and they get what they get. And so a good part of what we do is also looking at how to encourage people to recognize those opportunities to improve their product. Failure is not bad. It's actually just a piece of information. It's neither good or bad. It's just info. We can choose to use that information to everybody's benefit. And that's a big part of reliability engineering.
So how do you see especially in the part of the world or part of the country that you're in, the lean startup movement and lean development, design thinking, how is this meshing with the classical reliability approaches?
It actually really, I'm thinking in particular of the agile development process. It's kind of and it's carried over from a lot of the software focus where I think that essentially got its start into a lot of the startups and the hardware companies I'm working with, is that they'll very quickly explore 5, 6, or a dozen concepts and flush them out enough to get just rough prototypes and get far enough down the line to get a good sense, including the reliability stuff, not only the functional pieces, but also what technical challenges they're going to face when they develop it all the way out. As opposed to you come out of concept phase and you make a couple of breadboards and then you make your first prototype and then it's build, test, fix on one variant. In the agile approach, we tend to get a lot more input in that early concept, first round part of the process. Because
they call you in earlier, you're saying?
Yeah, that's a good way to summarize it. And that, I think, is the biggest benefit of it. The second part, here in the San Francisco Bay Area, there's not a lot of manufacturing. There's very few that manufacture here or in-house. There are a few. They're squirreled away every now and then in these parking lots. But the Lean Six Sigma stuff in manufacturing just makes a more capable manufacturing process. Right. It's stable, and that helps reliability tremendously. So I see it affect us in two ways there.
So there's some schools of thought that the agile or lean startup is releasing unfinished product into the market, kind of like how you described Microsoft, right? They do their best, but there's always something else, right?
I saw a graphic just the other day on LinkedIn. It was the minimum viable product, which is what a lot of startups are trying to do. They just have to get to market. They have to get it in customers' hands that proves their concept, basically. Yet it's at great peril that if every other unit you ship fails, and we mentioned Yelp earlier, it's a small world. Some of these companies don't get a second chance, and if they do, they have a bigger hole to climb out of because they're now perceived as a not reliable product. Might be a great feature, but if it doesn't work, we're not going to buy it. There's tremendous pressure on startups to get to market. The VCs and others want to return. You got to start generating revenue at some point. So I understand they don't want me walking in and saying, "Oh, you need to test for 6 months," and it doesn't really help them. But understanding the risks and understanding up front as early as possible where you can make things more robust, where the uncertainty is, where the risks are, can help them improve the design to improve their chances of getting to market successfully. And so that mindset of get it to market as quick as you can and let the customer sort it out. It was safer 20 years ago without Yelp in the review systems. Right. We used to call it a beta program, right? You'd send it off to 10 trusted customers, and that takes time. The world now is that cycle is so compressed that there's little or precious little time for beta type programs. And so the reliability has to be done up front. It just has to be. And it's just another task of all the other ones they're facing. So it's competing for resources like everybody else is.
So in the industries that you've been in, have you been working in this field long enough to see the effects of offshoring on reliability and those kinds of political, economic trends?
How long's the podcast supposed to be? I've seen plenty of stories. Now, I've worked all over the world, and with all kinds of engineers and factories and systems and designers, and there are brilliant, talented people all over the place. It doesn't matter whether it's a factory here in the States or factory in China. If you change lines, you move from one side of the room to the other one. Mm-hmm. It's never as easy as anybody thinks it is. Right. You just don't have the same alignment. You have the heating and cooling system affects your equipment differently. There's more or less dust. There's more or less variability. We all too often underestimate the ability to change something from one place to another, to build a prototype here and it's working, and then send it to a factory in China and have them build it. Mm-hmm. There's just way too many questions. And as many design teams know, is that it involves lots of time spent in China with your team to get it right and to convey what exactly you're looking for and what is good, what is not good. Mm-hmm. Is the drawings and prints and CADs often don't contain enough information to be successful at it. Mm-hmm. And yeah, there's plenty of problems. But even I've seen it where people are bringing stuff back to the States to manufacture, and we don't have the skilled and talent. We don't have the workforce that China had building, say, I'll use iPhones as an example. Not that they've come back that I know of. I think they're announcing they're building more factories. But it's another workforce. It's another location. It's another culture. It's another inherent way of doing business that's different. And so it may take you 2-3 years to refine and hone a process overseas and get it up to speed, and so that you can send a design and they can build it and there's not a lot of gnashing of teeth. Whereas the same in the States. If you bring a product back to the States, it's a relatively new team. They got new equipment. It's a new setup. It takes time to shake that out. You don't turn. Now, in Mexico, this is quite some years ago, as I was in Hewlett-Packard, and I was looking at a circuit board manufacturing line for one of these big circuit board contract manufacturing house. And they had just opened it was like 100,000 square foot factory space. And in the morning, we walked in and they had forklifts bringing in crates of new equipment, of pick and place equipment, soldering equipment, so on. This big equipment line. And in the afternoon, we're walking back out through there and they were running it. They were running their first proto lines on it, their setup stuff on it. And they expected to be running production on it the next day. Oh. And they were going to put in 40 new manufacturing lines in 2 weeks.
Okay.
Yeah. And, that doesn't happen by chance. And, but they had it down. They had put in so many lines and were very, very successful at it. It was truly impressive. Most of us don't make the exact same thing with the exact same equipment every day. So it's really hard to do.
So that was similar to the Intel model of, no matter where you are in the world, copy exact as much as you can.
That's right.
Yeah,
that's right. Yeah, and the hard part is that when we say do a visual inspection and make sure it's good, that is so unprecise or imprecise that if you and I looked at the same thing, we would probably see different things as being good or bad.
Mm-hmm. Absolutely.
And then you add cultural differences, and it just gets worse. Or more varied, I shouldn't say worse. More varied.
Imagine, if you will, you've got a blank slate of a student, maybe a high school student, who you want to build the perfect reliability engineer. How would you start building that person? What sort of degrees would they start off with, and what would you sort of carve out for a development plan?
That's an interesting question. I've looked at it more often from where do reliability engineers come from. And there's two paths, but how to groom somebody to be it. I wish I would have remembered her name. I was grading or judging a 6th grade science fair years and years ago. and there was the cross section of a volcano, and there was, three plants on one side of a little egg carton that were watered, and the other side were not watered. And this experiments, which one would survive? Pretty simple, not a lot of thought going into some of these things. They went through the motions, and except for this one young woman, her experiment was asking the question of, if you play a particular sport, do you have an inherent muscle memory? And she had to figure out what the right word was in talking to physiologists and sports trainers and stuff. But if you played soccer, do you have an inherent muscle memory in kicking a ball and does it translate to throwing a ball? Hitting a target, is that what you are good at, or is it the physical movement that causes the target to be hit successfully?
Okay.
It was kind of, I think she was on a soccer team, so she recruited her team. They took 10 shots at a target, and then they blindfolded them and took 10 more shots. Mm-hmm. And she was counting how many successes they had. And then she went to a baseball field and did the same, had him kick at a target 10 times and then blindfold kick at a target. And then I think her father knew a statistician at work or helped her work through the hypothesis test, but they just ended up doing 2 histograms, which was sufficient to really show the difference. Mm-hmm. And it was true. The soccer players, could kick and hit targets blindfolded way better than a baseball. And then she reversed it. She had the soccer players throwing a baseball and so on. It was an interesting experiment. She did a lot of research and work to design it and to implement it and stuff. That was very creative. But in the interview with her, talking about her project, she had 20 more questions. And she had already gone off and done experiments on 3 of them.
Oh, wow.
She didn't have a business card, but I wish I would have kept track of her.
Right.
Because I would have hired her right out of school. The grooming part, the blank slate part, is the best reliability engineers, in my opinion, are the ones that ask the best questions, that they never stop asking questions. And it's insightful, measurable type things you can go run off and do experiments on. And then a healthy dose of creativity. Well, how do I measure that? You can learn the statistics, you can learn the engineering, you can learn the chemical analysis parts, that stuff we can all learn. And that's a big part of our schooling. And you and I, we continue to learn all the time. And many of our peers are constantly picking up new skills. But if they don't have that inquisitiveness and creativity, I don't think they're as effective. They don't learn as fast. They don't want to learn as fast. Mm-hmm. I think those are all tied into it. The hard part is that our school system tends to beat that out of people by the time they get out of high school. So it's right. Blank slate would be to foster those attributes and then add the technical stuff as we go, but keep the inquisitiveness and keep the ability to ask good questions.
That's a great story. Thank you for sharing that. That's actually sounds like a great place to end. So is there anything I didn't ask that you'd like to share?
You've heard my podcast. I could talk on and on and on about reliability. But I do want to mention that one of the places to learn reliability, whether you're a blank slate or not, and your question, Aaron, made me think I should add more about asking good questions and inquisitiveness, creativity type stuff on the site. But the website Accendo Reliability, ACCENDO reliability.com, is a platform we're building. The idea is to have many voices providing professional educational material and content like podcasts and webinars and courses and ebooks and lists of references. We pull from as many different meaningful sources that we can find in the quality and reliability sphere and make it a one-stop shop. Mm-hmm. You can find all this stuff there. And then I think I have about 15 folks that are working on the site providing a range of different kinds of content, and we're always looking for other contributors to the site. So if you're familiar with Udemy or Coursera, we're trying to do that with the niche of reliability and quality engineering. Okay, interesting. So how long have you been at building the Accendo site? It's about the 2-year anniversary. The podcasts were a little shorter than that. I think we're about 18 months in. We just went over 300,000 downloads. We added 100,000 downloads in the last 3 months. So we're growing nicely there. And it's been across the whole range in the reliability.fm podcast network. But the daily visits, the daily page views, the amount of comments and engagements and shares, all of those kinds of things are just keep trending up and kind of in a nice pattern. So we're pretty happy with that. So it's getting some traction and starting to attract more offers. People want to list their products there now. And so it's one of the signals that it's successful is that it's the place to be kind of thing. So a few are starting to explore that. So that's all been good. It's a way to offer a good course to the audience that fills a niche or a need that they may have. And it's educational ebooks and books, textbooks types, and using the Amazon affiliate market,
right,
or some self-publishing stuff, and courses online or live, and webinars. We're going to be starting a paid webinar program here in the next few months. So we're kind of gearing up to sort out all the mechanics of doing that.
Mm-hmm. Okay, so where can people best get in touch with you?
Well, I'd say the Ascendo reliability.com site. All of the contributors have an about page, and it has multiple ways to get in touch with us. It's probably the easiest one. I'm also pretty active on LinkedIn. It's a pretty easy place to get a hold of me too.
All right. Thank you very much again, Fred, and I look forward to speaking with you again.
All right. Great. Thanks, Aaron. And thanks again for the invite.
My pleasure. Thanks for listening to episode 181 of the E6S Methods podcast. Don't forget to click like or dislike for this episode in the show notes. Tap click done. If you have a question, comment, or advice, leave us a note in the comments section or contact us directly. Feel free to email me, Aaron, AARON, at e6s-methods.com, or on our website. We reply to all messages. If you heard something you like, then share us with a friend or leave a review. Don't like what you heard? Join our LinkedIn group and tell us why. Don't forget you can find notes and graphics for all shows and more at www.e6s-methods.com. Journey through success. If you're not climbing up, you're falling down.